All right, here we go into video 2 in lesson 5.6 already. That's crazy. We're crushing it. In this lesson, we're going to go over the derivative of a to the x or a to the u. Basically an exponential function where a can be any number, not just e to the x. So we're going more general here. So without any further ado, I'm going to show you what the formula is. The derivative of a to the x is just like with e to the x. It's still a to the x. But then we've got this times ln of a. I'm going to go over why that's the case at the end of this video. But for right now, I'm going to teach you process first and then talk about why that works. But think of this as e. That's how you're going to remember this formula. I'll show you in a second. So derivative of a to the u, well, that's going to still be a to the u times ln a. Don't forget about your u prime. And in fact, it might be easier if you remember it just like you would do e. So it's like a to the stuff d stuff times ln a. That's just like e. And e to the x is the same exact formula. It's just a specific form of a to the u. The only difference, when we take the natural log of e, right? So when we were doing that, it would be e to the u prime. ln of e, that's 1. That's why we never saw an ln e. So that's why when you took a derivative of e to the x, it was e to the x times ln of, well, 1. Not ln of 1, sorry, ln of e, that a value. So that's why the derivative of e to the x was just e. That went to 1. So that might be a good way to memorize it. It's not why this works, but it's just food for thought. So now we're going to go over what happens when the base is not just e. You use your formula. That's it. So this is going to be the derivative of that, y prime, is still 6 to the x times 1, right? So 6 to the stuff, d stuff is going to be times 1 times ln of 6. That's it. That's your derivative. This one right here, it's just going to be like e. So normally we would do e to the stuff. This is going to be 3 to the stuff, d stuff, the derivative of sine, that's your chain rule right there, is cosine x, times ln of 3. So we have that extra ln part that we need to remember. Let's rewrite this a little bit neater. So I guess we do ln of 3 cosine x times 3 to the sine x. There's a number of ways you could write that, but that works. Now what happens if you got a product? No sweat. You got this. Product rule. Right? But it's no different than any other product rule. It's just that when you get to doing 4 to the stuff, we've got to exercise our new formula here. So that's the first function, that's here, times the derivative of the second function. So that'd be times 4 to the stuff, d stuff, that would be times 2x, the derivative of that, the chain rule, times, don't forget about your ln4. That's first d second, plus second, d first will just be 5x to the fourth. That's not bad at all. We'll neaten it up just a little bit there. And that's pretty gnarly looking actually with all this. 2x times x to the 5th is 2x to the 6th times 4x squared minus 3 times ln4. And we can neaten that up. You can put the ln4 out front here. Some people might write it as 2 ln4 x to the 6th, 4x squared minus 3. It's a mess. Plus, and then we'll do 5x to the 4th times 4 to the x squared minus 3. It doesn't look good, but it's easy enough to do. Follow that formula. That's it. Think of it as e to the stuff, d stuff. So now, that's all. That's all there is to it in terms of this video and the process. What I'd like you to stick around for, though, is to see why the formula works the way it does. So we've seen that y prime is equal to a to the stuff, d stuff, times ln of a. The question is, why? To figure that out, we're going to actually use logarithmic differentiation. If you forget what that is, check that out from an earlier video in lesson 5.1, but go over it again. I'm going to take the ln of both sides, right? What that allows me to do is play in the clouds, so to speak. I can now pull that u out front. I'm going to take the ln because it's the easiest thing to derive. U comes out front with our log rules. ln of a is a constant. It is not a variable. That's what allows this thing to work. It is a constant, any number. It could be 3, 4, 2.7, 8, any number. Now we'll take the derivative of both sides with respect to x. This will be 1 over y times y prime, or dy dx. That's equal to, well, the derivative of u is just u prime, right? That's with respect to x, or du dx. ln of a is a constant. There's no product rule there because it is a constant. It's very important. So now we multiply both sides by y to solve for y prime. That's what we want, the derivative. So y prime is equal to y times u prime ln of a. Wait a second, what's y? Y is a to the u. So that's a to the u times u prime ln a. And there's your formula. So this is actually the general formula. Had A been equal to E, again, we would have had ln of E. We would have had e to the u times u prime times ln E, which is 1. Ln of any other thing besides E is not usually a nice number. And that's it. That's why the formula works. For those of you that were curious, it's not bad. Follow your formula, know your formula, and know how it relates to e to the stuff. Peace.